So let's talk about everybody's favorite, word problems. Okay, it's basically just math in a sentence. Okay, so we'll pull up a word problem here. Okay, so there's the question. What is the length of a diagonal brace used to support a table that is 120 centimeters wide by 50 centimeters tall? Now, nowhere in there did we say the word triangle. So it's not really immediately obvious what we're supposed to do here and how does it relate to trigonometry. So the best first step that you can take is to just draw out the problem. Okay, so let's just draw out, we got a table here. So I'll just draw a rough table here, 2 table legs, 4 I guess, we're just looking at it from the side. Okay, we know that this table is 120 centimeters wide. Right, so from one end to the other it's 120 centimeters. And we know that it's 50 centimeters tall. Okay, we also know that there's a diagonal brace. So if you've seen like those folding card tables, you've seen like a brace that goes across just to make sure that it stands up. There'd probably be one the other way as well, but for our purposes, we're just talking about one of them. And it's asking what is the length of diagonal brace. So we stick our X there because we don't know what that is. And suddenly, instead of seeing a table, we can see that there is a triangle here. Once we line it up all graphically, it becomes much more obvious that there is a triangle here. We can solve this, right? So the question becomes, what do we use to solve this? Well, we know that we have a right angle here, which means we're solving for our hypotenuse. We have 2 sides solving for the hypotenuse. So that tells me that we should be using Pythagorean theorem, which, if you'll remember, is a squared plus b squared equals c squared. Okay, so if we use a little bit of math here, we get, stick in the numbers, we get 50 centimeters squared. And again, it doesn't matter which one is a, which one is b, it just matters that those are the short sides and that c is our hypotenuse. So 50 centimeters squared plus 120 centimeters squared equals x squared. Okay, so now we can just complete the math here. So 50 squared, or 50 times 50, is 2,500, and that would be centimeters squared right now, since the unit is squared as well. Then we have 120 times 120, 120 squared there would be 14,400. That would be centimeters squared. And that's still x squared since we have no idea what x is. Okay, so now we're just going to add these together. Pretty simple. We get 16,900. And again, that's centimeters squared equals x squared. And if you'll remember the last step, to get rid of that square, we have to take the square root, which gets rid of the squares. And we'll take the square root of 16,900, which gives us 130. Whoops, I don't want that in red. Which gives us 130 centimeters. Okay, so there we go, from just a jumble of words to the final answer. Okay, so that's one example, but the big thing about word problems is that they are widely varied. So we'll take a look at one that maybe requires a little bit more logical thinking, and we'll kind of walk through that one. So let me just pull another one up here. Okay, so this one's a little bit longer, but we'll take a look at it. So the Pyramid of Khufu is approximately 140 meters tall. So think like the Great Pyramids here. I don't know, is that a good pyramid? Close enough. If the base is a square, so the base is a square, with sides measuring, whoops, that was a bad square. With sides measuring 230 meters, what is the slant height from the center of one of the sides of these pyramids? So it's asking, what is this measure? What is that slant height there? Okay, so a good thing to note here is that we can make triangles where there don't appear to be any. Okay, so if we were to imagine, say that we had, let's make that a little bit bigger here, say that we had this, this pyramid here, we imagine that instead of just being this diagonal line here, that this diagonal line, we could drop another line that goes down to the center of the pyramid, right? So this is going down right to the center of this base here. And then we go out from that base out to the side of the pyramid. So now we have this nice slice that is triangular. Right? We have this nice triangular slice wherein the slant height is here. Right? That's the slant height. I'm actually going to use S for the slant height here. Makes it a little bit easier here. Okay. Then the height of the pyramid, the actual height of the pyramid is here, which we know is 140 meters. And then we just need to know one more side or an angle or something else. But we know that the base of the pyramid is 230 meters on all sides. And if we drop a line right into the center of it, right, we're cutting this in half. Right? So if this full side is 230, then this half side must be half of 230. Which should be 65. No, not 65. That's half of 130. That would be 115. Pardon me. Okay, so we know that's going to be 115. And we know the height is 140. So there we go. Now we have a triangle. We have a side here, we have a side here. We know that this is a right angle since we dropped it straight from above and out to the side. So now we have another Pythagoras question. Since we've got two sides and we're solving for the hypotenuse. So let's solve this here. So a squared plus b squared equals c squared. We'll call this a, we'll call this b. Again, it does not matter. So that's 140 meters squared plus 115 meters squared equals s squared, since we used s for this side length here. Okay, so now we just take our 140 and we square it, which will give us 19,000, an actual marker please, 19,600 meters squared, square meters. Okay, then plus our 115 squared, which is going to be 13,225 meters squared, and that'll be equal to our s squared for now. Okay, then we add those up, will give us 32,825 meters squared, and that's still the side length there. And then we find the actual side length by taking the square root of both sides. And if we take the square root of both sides, we should get square root of calculating. We get 181.2 as our side length. And of course, that'd be meters, my bad. Okay, so from a three-dimensional shape, using some logic to find a two-dimensional shape inside it, figuring out what the side lengths of that two-dimensional shape would be, and then just some Pythagoras to finish it out. Okay, so let's do one more, just to kind of round ourselves out here. Okay, so last one. Plane travels 12 kilometers along its flight path. So we got a plane. You're going to see me have to draw a plane. Oh. Like that-ish. Maybe a little bit more like a space shuttle. Or a hot dog. I don't know. Okay, so let's call that a plane. Fields are important. Okay, so it's flying along its flight path 12 kilometers. So it's flying, you know, up-ish. Maybe not this high, but it's exaggerated. But it's flying along 12 kilometers. While climbing at a constant rate of 8 degrees. So it's gone from the ground level. It's climbing at a rate of 8 degrees. Okay, so we're asked, what is the vertical change in height during this time? So vertical change, we'll call it h for height. Okay, we have an angle. We have a couple of side lengths to look at here. And if we use our imagination a little bit, we can think about, you know, Earth down here as our third line to give us our triangle. Okay, so this time we don't have two sides solving for a third side. We've got an angle and a side, which means we're going to have to use some form of SOHCAHTOA. Okay, so first things first, let's label some sides here. So if we look all the way across from the angle, we see our opposite side. If we look across from the right angle, we see our hypotenuse. So we're looking for hypotenuse and opposite. Looking at SOHCAHTOA, we look at sine. We've got sine, which has opposite and hypotenuse. So right away, there's our choice. Okay, so we use sine of theta equals opposite over hypotenuse. Okay, just like we did in previous videos. Now we can start filling things in that we know. Sine of 8 degrees equals our opposite side of h over the hypotenuse of 12 kilometers. We need to get h on its own, so we got to undo that divide by 12, which means we have to do the opposite, which is times. You go times by 12 because to get rid of something you do the opposite but use the same number. Those two cancel. Then we do the same thing on the other side because math is fair. Okay, so we just rewrite this below. We've got 12 kilometers. Whoops, didn't write again. 12 kilometers times the sine of 8, which is 0.1392. And that's our h. And then we can multiply those together for our final answer. We get 1.7 kilometers. Is our height. So it has risen 1.7 kilometers over that distance. Okay, so it kind of zipped through this part here just because we've done that kind of solution on the previous videos. The important thing to take away from any word problem in any part of math is that in there somewhere there is a solution, there is something to solve for. So modeling the problem, drawing it out, talking it out, and trying to figure out where the patterns are, the things that you can solve for, the things that you have, and the things that you're missing are an integral part of finding this final solution. So again, start with just drawing it out, and then eventually you'll be able to find a way to solve it yourself.